that is sufficient. But information about the topology in a local area must be very precise, otherwise we have those routing loops. We can of course not grant that still the problem of routing loops can occur, but I think with the new release, which is currently untested, and I hope people start using it really soon, you can get it from the CVS part. It's for Linux, it's ready to release, but we're waiting for feedback from the people using it on BSD, Mac OS X, and Windows before we issue the 0.4.10 release. Yeah, 0.4.10, I hoped we would have released it until the 23rd of December, but it's still not released yet. But like I said, you can already use it for Linux. It should work really well. We're already testing it here. We hope that we get feedback from the other OSs. Already, if you still use 0.4.9, it's reasonably stable for smaller meshes. If you only stick to ad hoc mode, it works with 100 nodes quite well. If you mix it with multiple interfaces, and if you have infrastructure link, it works up to 200 nodes. Yeah, there's some new features like a plugin interface. We have a web-based tool for monitoring the state of the mesh. And we have the link quality fisheye algorithm. So I hope I didn't bore you. Thank you for your attention. Pardon?
Country coverage, wide areas, not on the local base. Oh.
Please use a microphone.
Are there any projects regarding to use this technique in a wide area network, not only on ad hoc mode systems, to adapt the protocols like the fisheye mode or stuff like this?
The technology that we are developing is intended to be used in a subnetwork. You can build a subnetwork in a quarter of a town, in a district of a town. You can use it mobile with friends on your laptop, on your PDA. It's not intended to route a whole country or a huge city. It's not possible to do it. There's clearly a limit to what a proactive routing protocol can scale. There are some theories of people that work on reactive routing protocols that only generate routes on demand, that don't have to maintain routing tables all the time. They're very optimistic. They say their subnetworks and their mesh routing protocols could scale to 10,000s of nodes. But I have my serious doubts that they can achieve it, especially because all the failures that we have seen in our real-life tests are still there. They're still happy if they find the shortest path, and that is clearly not enough to have a mesh that works.
Sorry, did you think about AND-like routing schemes? Like I heard the routing scheme used by ants.
By ants?
Ants, yeah, like ants, if they try to find something.
I have to admit not, no, I cannot say anything about it.
They just go out somewhere and leave some chemical substances, which evaporate eventually, and the more ants they take that way, the stronger the substance track will get. Mm-hmm. And people were thinking about emulating something like this for routing.
Well, I have to admit I didn't look into that. I still stick to the proactive approach. Of course, it is a good idea to look into the nature, and there are many algorithms that you can see in nature and reuse. This is, of course, a good thing, yes. but I cannot say anything about it. And of course, there's several approaches to mesh routing. It's not only the proactive or the reactive approach. If you check out the English Wikipedia page about mesh networking, you'll find many papers and many different approaches. Amongst these are graphical routing protocols, where you have geodetic data and route according to geodetic data. Other protocols are clusterized, are working with a hierarchical ideas. And I know some people at the university here in Berlin are working on it, but they're still, as far as I know, they're not addressing things like interference, like finding really good routes. I think they're quite happy if it works to some extent.
I noticed you had like 1 second updates or something like that, and it seemed like very short intervals. Is it because you want to allow nodes moving around, changing positions, people walking with their laptops, or is it because you want to detect nodes that goes offline? You want to detect that very fast?
In fact, at the moment we are migrating from relatively long topology control intervals of, I think, about 5 seconds or 4 seconds to half a second or 1 second. 5 seconds is a lot of stress for the mesh because we have so many nodes. But in the future, when we use that fisheye feature, those topology control messages, like I said before, they don't travel far, so we can issue them very frequently. So we can keep adjacent neighborish nodes up to date with routing information, with information about the quality of their links. And this should, I'm very convinced that this will give the project and the software that we provide the next bigger boost. The last boost or biggest improvement was ETX, and although this fisheye routing thing is a very simple hack, I'm very convinced that it will be a big improvement and move OLS RDaemon to the next step. I can tell you that we are now in the development dropping the backward compatibility and those features that allow to configure OLS RDaemon to be backward compatible with the old NVIDIA drafts. We will completely drop it in the 0.5 release and further. 0.4 will only contain bug fixes in the future, and I think it will, it's deprecated and it will not go so much further. 0.4.10 again has a new feature and is still on the bleeding edge of the development, but with the beginning of the next year, all this development will only happen in the 0.5 release.
If you have a wireless network with multiple uplinks or peering partners, how good is load balancing possible?
Load balancing, no, we don't have something like that. At the moment, all that OLSR does is find the next gateway and use it. And there's still an unresolved issue if you are between two internet gateways and you have a SSH connection. Perhaps it could happen that the protocol designs, okay, now I choose the other gateway, now I choose the other gateway, and this is of course annoying because we usually do network address translating on the gateways, and your SSH connection will break down. This is of course an issue. You can, with some handwork, you can manipulate which gateway you in fact choose, but this is handwork. There's no automated solution for it at the moment. This is still an unresolved issue. We're still working with one interface, although OLS RDaemon can handle multiple interfaces. In Berlin, many people are using OLS RDaemon on their machines. They have several interfaces, wireless interfaces, Ethernet interfaces. They enable OLSR to send hello messages on all interfaces and let OLSR do all the design of their network. which is quite tempting, and I like it. It's not like intended, but it works. And we can boost the performance of the mesh if we start using more devices that have several wireless interfaces on different channels, so we don't have so much interference. That will give another big performance boost. I expect commercial companies that are going to develop mesh solutions to go more and more into this multiple interface ad hoc part of the mesh thing. We can expect it real soon. At the moment, the solutions that I heard about from Cisco, perhaps they have a very expensive mesh router that costs $5,000. It has 2 wireless interfaces, but one is just in use to provide infrastructure network to the clients, and 1 ad hoc interface to provide a backbone structure to connect to the backbone. In future, there will be devices that have several interfaces working all in ad hoc mode, of course. This will be the next step, but well, my intention is to have a community network that is cheap and has range covering large areas, and if we start moving to have several wireless interfaces in each device, this is of course a cost factor. It will give enormous performance. Yeah, but it will cost. I expect for the community this not to happen so soon, but it will happen in the commercial development of mesh networks. Yes, I heard about it. There's one company, and they have really impressive papers about, hey, we solved the mesh issue. We have now several interfaces. Well, yeah, sure.
Can you say something about how this routing algorithm reacts to very fast-moving nodes?
The mesh networks that we use, they are mostly static. If I'm frank, I have some doubts in my work because I'm afraid that people in the military will use it. It may be used for surveillance, and of course they may benefit from our work, and I know that they have a close look at what we do. My idea is not to develop something that couldn't be used in a tank or robot-driven bomb on a battlefield that is moving rapidly around, or somebody riding on a motorcycle and using a mesh network. That's not my vision, and the work that I do is not pointing into that direction. Other people, of course, work into that direction.
Okay, one question. I realize you have link quality information now factored in by packet loss, more or less. However, that's not the only consideration. Obviously, we can have very little packet loss in a low bandwidth link, while some nodes which are closer by, while they might have some packet loss, the link might still provide more throughput. It's probably hardware dependent, but are there any developments where you would factor in signal noise ratios or the effective link speed into the protocol?
Yeah, well, we thought about it, but what we do is providing a help for community networks, and community networks have a heterogeneous hardware structure, and so the lowest consensus that we could use amongst all those different hardware with all those different drivers was to implement ETX. That was and is, in my opinion, a good step forward, but of course it is not perfect. The perfect solution would be to have a hardware that does all this in firmware. That does, if a company starts developing something like this, and create their own standard, or hopefully an open standard. They can measure signal to noise ratio, they can measure the throughput, and they can measure everything. But it's impossible to do this with that solution that we have here, where we have just a user space program that runs on several different operating systems with